All right, guys, today we're going to talk about polynomial functions. Polynomial functions are just, of course I didn't get this started, just crazy stuff like this, okay? Might be doing a whole bunch of loop-de-loops. These are polynomial functions. We're going to analyze the graphs, which we have already done, right? We did maxes, mins, all that good stuff. We're going to talk more about end behavior and how we can predict end behavior without actually graphing it on our calculator. That's very important because you all have graphed something on the calculator and been misled by what you could see in a particular window, right? So if we could predict ahead of time, it would be good. We're going to talk about the degree being even or odd and the multiplicity being even or odd and the difference between that and an even or odd function. So we're going to have 3 different ways we use the words even and odd today. All right, so quick warm-up. You had to do this on the pink sheet last week. Anybody remember how we factored an x to the 4th that only had an x squared? Yeah, we did an x squared and an x squared because x squared times x squared, you'd add the exponents and get x to the 4th. Factors of 3 that would make 4, I'm only thinking there's 3 and 1, right? To get a positive 3 but a negative 4, 2 negatives. Okay, we'll just stop there for now. I mean, this one would factor further, right? But let's just, it's a warm-up. Anybody remember what we do when there's 4 terms and we have an x to the 4th, x cubed, x squared, and an x? Yes. We could take an x out of the whole thing. But we still have 4 terms. Anybody remember what the only way we know how to do 4 terms probably is? Yeah. Let's group. So let's leave this x alone out here, this guy, okay? What could we take out of these and what could we take out of these? I know exactly what Kelsey meant. An x squared out here. So we got that guy out front still. And an x plus 2. Now, in this parenthesis, remember we need an x plus 2. But what goes in front of it? Yeah, just a plus 1. Okay. So now you got to be a little bit careful because you can't smush these together. I should put another parenthesis there, I guess. So we have that x out front. If we pull out the x plus 2 here and here, what smushes back together right there? X squared plus 1. Okay, that was icky. All right, let's try this one. This one's not so bad. Just pull out an x. Always look for the common factor first. And then how would the rest factor, guys? Minus 5 and minus 4. Does that go further? Can't as long as you're down to x's, right? And one more of these. X squared and x squared. 8 factors of 8 that differ by 2. Minus 4 and plus 2. Does that work? X to the 4th minus 4x minus 8 and a, what did I miss? This guy, plus 2x. All right, and then, yes, this first one really would have gone. All right, I'm going to do some more fun with those in just a few minutes. All right, so today's lesson, we have already talked about all the monomial functions. Monomial means one term, like we did. We've talked about that as a parent function. We've talked about this. We graphed some of those goofy ones in the last chapter. Or the last section, I'm sorry. We did negative exponents. Okay. Now, to be able to call these a polynomial function, the power can't be negative, so this one would not be, and it has to be an integer. So these are not going to be polynomial functions, but anything with, what's the difference between a monomial and a polynomial? Yeah, poly means a lot or more than one, and mono means one. So we had this term. Now we're just going to have crazy things like this. Okay? So they're not all just going to go through the origin anymore and that kind of thing. Do you remember how to find the degree of a polynomial? This is really important. The degree of a polynomial is the highest exponent power. So the one I wrote down here is degree 3. Now be careful, because if I threw an x to the 5th on the back of that, now it's degree 5, okay? They'll slip those in there. The leading coefficient is whatever is multiplied by that term that had the highest degree. So this had slipped in the back, so the leading coefficient would be 7. If we rewrote it in standard form, putting the highest exponent first, then it's really makes more sense to call it a leading coefficient. But all right, I just covered half the lesson in one slide there. So you've already seen constant functions, linear functions, quadratic functions. We've even done cubic functions. But the generic term polynomial, a polynomial function is graphed as a continuous function for all real numbers, and it will have smooth rounded turns, okay? So a absolute value doesn't count, and anything with a break doesn't count. So when we did these as monomials, if it had an even degree, it either looked like this or this. If it had an odd degree, it either looked like this or this, okay? So if we take our concept, this is an odd power, it would have this shape, and this one would be shifted where? These are our transformations. You don't have this one, but what's happening here? What does a -2 inside do, guys? To the right 2. So it would shift it to the right 2. What 2 transformations have happened to this basic shape? It's an even power. It's flipped upside down and up 1. Okay, so up 1, upside down. So just a couple more to practice. I don't think you have these either. Maybe you do. I don't know. This is a degree 3. So the parent looks like this. Everybody good? What are we going to do here? Be careful. How could I rewrite that so it would feel more comfortable? Okay, so what are the 2 things that have happened to that graph? Flips, so now it's going this way, and up 4. So it's up here somewhere doing this, okay? And this is degree 4, so it's basically this shape. And what is this one has happened to that one? Careful. It's inside, so it's left 7, right? It's over here somewhere. What? Okay, so the end behavior depends on the degree and the leading coefficient. Okay, the end behavior, whether it's going up forever, down forever, left end up, right end down, etc., depends on the leading coefficient and the degree. It says the leading term test uses the power and coefficient to determine the end behavior. Now, it does say down here, this is just a warning, and we already talked about this, but the leading term is not always first. Everybody good with that? That they could slip that highest exponent power in later in the problem. All right, so the leading term test says, if you have an odd degree, degree 3, degree 5, the ends are going to go opposite directions. That seem okay? We all are supposed to have memorized that this is a cubic shape, right? Ends go opposite directions. All right. If it has a positive leading coefficient, the left end is always down and the right end is up, just like this. But as soon as we put a negative out in front, like a negative x to the 5th minus 7x squared plus 13x minus 9, some disgusting thing like that, the shape is just going to be upside down, right? So if you flipped this because of the negative, the left end is going to be up and the right end is going to be down. Now, there could be a whole bunch of jazz going on in the middle, and we're going to talk about that. but we're talking about end behavior right now. If it's a positive degree, like an x to the 4th or an x to the 6th plus garbage, okay, then if it's positive, both ends will always open up, just like a parabola. If it happened to have a negative leading coefficient out here, then both ends will open down. All right, so that's what this little chart is for. It says degree is even, leading coefficient is positive. So an example would be like 3x to the 4th minus 7x plus 5. That's leading coefficient is 3, degree is 4, and the shape would be both ends up. I don't know exactly what it looks like, but I know both ends are going to point up. All right, can anybody tell me what the same degree does with a negative out front? You should know this from your transformations. What is the leading, if I change it to a negative out front? It's going to flip it upside down, so both ends are going to point down. Okay, there could be a whole bunch of loop-de-loops in there, but both ends are going to point down. So we could have like a negative 12x to the 6th minus x to the 5th plus x squared, blah, 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 blah. But the leading coefficient is here, and the degree is 6, even degree. Now, is this an even function? Talk more about this and put some notes down, but does everyone understand that I am talking only about the degree, the highest exponent power? An even function is symmetry, right? I can draw this shape, and it has no symmetry whatsoever, right? This would be an even degree, negative leading coefficient, because both ends are going down. But it is not an even function because it doesn't have symmetry. All right, odd degree, positive leading coefficient just means left end down, right end up. Okay, like a 4x cubed minus 2x plus 5. The leading coefficient is a positive 4, and the degree is odd. If I have a degree that's odd, but a negative leading coefficient, it flips over, and it could have a bunch more loops in the middle, but the left end is going to go up. Okay, so I have negative 5x to the 5th plus 4x squared minus 9x plus 10. I don't know, I'm just making up stuff. Again, the negative leading coefficient, odd degree. Whether the coefficient is even or odd does nothing. The big number out front, all that matters is whether it's positive or negative. But the power, whether the power, the highest power is even or odd, okay, determines whether the ends are pointing the same way or opposite ways. All right, so let's write this in our notes. You have a spot to write this down. It says, what is the difference between even odd degree and even and odd function? Okay, even odd degree determines end behavior. Okay. So even would be both ends going the same way. Odd would be opposite directions. Even and odd function okay, what was that tied to? We're supposed to know this, guys. What does it mean if a function is even? What? Symmetry, yeah. Even or odd function determines symmetry. Or is related to symmetry. I don't really know if determines is a very good word. So an even function would have y-axis symmetry like this. An odd function has what kind of symmetry, guys? Origin symmetry. So it might look like this. Okay, I didn't draw that very symmetric, sorry. Now, it is true that an even degree can be an even function, but it doesn't have to be. Do you see mine here? Definitely doesn't look like it would have symmetry, right? Especially if I slid it over here. That's an even degree. Odd degree could be an odd function, but if it looked like this, it doesn't have any symmetry. Okay? Those are the difference there. This one is just an example. It's done for you on your paper. They graphed it. It looks like this. They just want you to write down the end behavior. Okay? I just redid it on the calculator and changed the window a little bit because this one looks like it's almost going straight up, right? And it is actually getting wider. So the domain would be all real numbers. Everybody good? There's no x in the denominator, no radical. The range would be, we'd have to find this minimum down here. I don't know what it is, negative 1 point, blah, 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 blah. And up. Okay, but we want end behavior. I just want to cry a little when I read some of these because it's not going well for some of you. How do I say the x is, I want to talk about the left end. The left side means that x is going towards what? The x-axis is pointing to negative infinity. On that end, the actual function value or the y value is approaching what? Going up on that left side. So I say approaching infinity. So that reads it's up on the left. All right, and this same function is doing what? How do you want to say the other one? How do you say it's on the right? X is going to positive infinity and up is y is going to positive infinity. All right, any questions about that one? So real quick, tell me same or different for this one. What's the degree? Degree 4, so it's even. So both ends are going to point the same way. What is a positive 3 going to make them do? Yep, both are going to go up, okay? Which means you'd have write out just what we did for the last one, right? Both ends are pointing up. What about this one? This is a trick question. Does anybody see why it's a trick question? Yeah, the degree is actually odd, right? What does that mean when the degree is odd? One end's up and one end's down. Okay, this is normally a degree 3, but this negative means the left side is up, right? And they could be doing a bunch of stuff in the middle, and then the right side is pointing down. This is what the graph looks like. It's about like mine. It's disgusting, right? But to write you would say oft x is going left, x is going right. As x goes left, y is going what? On the left, it's up. This one says, this says to the right, so you would say it's going down. All right. Now, real quick, when you have degree 3 or cubic polynomials, and we've also talking a lot about degree 4, which are also called quartic, okay? So degree 3 can have like no maxes and mins, like this, or it could have one max and one min, or what are called 2 turning points. A degree 4 could have only one min, okay? Or it could have a max, a min. So 3 turning points. The maxes and mins are called extrema, but they're also, it's called a turning point in the graph. Everybody get when I say turning point? Just means the graph changes direction. So this is the rule, okay? Functions change from increasing to decreasing at turning points. Increasing, decreasing, increasing. So there's a turning point here and here, otherwise known as a max and a min, or local max and min. Cubics have at most 2 of those. Quartics have at most how many turning points? It's degree 4. Max, min, max. So 3 turning points. There's a rule we need to know. Okay, if this was degree 3, how many turning points did it have? 2. This was degree 4, how many turning points did it have? 3. What do you think? Yep, it's always 1 less. You should have learned this last year, I think, but I'm not positive. So anytime for polynomial over degree 1 has at least at most one n distinct zeros. Okay, let me try that again. So if you have a degree 3 polynomial, we've talked about this in the past, that it can have at most 3 zeros, right? Okay, but the turning points is going to be n minus 1. So will you write this? I forgot to put this in your notes. Okay, so just at the very bottom, just write yourself a note that says the degree is equal to the maximum possible number of zeros. Doesn't mean it always has that many zeros. And the degree minus 1 is equal to the maximum possible number of turning points. I'll give you a second to write that at the bottom of your notes. That's important wherever you want to write it. I thought maybe there was just room along the bottom, but the degree of n gives you the maximum number of zeros, and the degree minus 1, or n minus 1, will tell you the maximum number of turning points. Easiest final exam question ever. Okay, give you a polynomial, say find the degree, tell me how many turning points it's going to have, how many possible zeros it's going to have. Easy peasy. Everybody got down what they want? Anybody waiting? Need me to wait? All right, a little more vocabulary. When we talk about zeros, we use the word zero on the calculator, right? We say, I'm going to find a zero between, and we put a little line here and here, and it finds this. But that zero can also be called an x-intercept, right? So x-intercepts and zeros we're good with. It's also called a root or a factor. A factor is slightly different because if this was at -3, the actual factor would be x plus 3. Does everybody make sense of that? Okay, so it also can be called a solution. So we have more words than we want for that. It's a root, it's a zero, it's a solution, it's a factor. What did I miss? It's an x-intercept. All right, so looking at this funky equation here, it says state the possible number of real zeros and the maximum possible turning points. So what's the degree, guys? Degree 3. So the number of zeros is at most what? There's a max of 3. And turning points would have a max of 2. And then it says determine all the zeros by factoring. So we had how many terms here? We had 4 terms, so our best bet is grouping. If we take an x squared out of the first 2, we're left with an x minus 2. We want an x. Did I copy this wrong? Oh, yes, I did. This is a plus. My bad. So we take out an x squared. we want the second parenthesis to always be the same as the first parenthesis. So what do we need to take out? A -1, okay? So if we take out this x plus 2 thing, what's left over is an x squared minus 1, but what could we still do to that? Yeah, that's the difference of two perfect squares. So then we wind up here. Now can you predict where the zeros are at? If we set this equal to 0, we'd have a 0 at x equals -2, -1, and +1. If you graph it, okay, it's going to cross at -2, -1, and +1. Can you tell me which direction? If I start on the left, is it starting down or up? You should be able to predict that. X cubed, what's the shape look like? Looks like this, right? Left and down. So it's going to come from here, come back through here, and go up over here. I don't know how far up or down it goes. But guess who didn't have a graphing calculator in high school, okay? I had to learn all this stuff, and then if I really wanted to know how far it went in between those, I would have to like test some values. But you're going to have to be able to sketch a rough graph like that and predict ahead of time the shape. You will get to use your calculator to find the actual maxes and mins in between. All right, so you do have these two. What's it say for possible real zeros here? How many possible? 4. How many turning points then? 3. Can we factor this? The degree 4 with only a degree, an x squared and a constant. So we can factor it x squared and x squared. Now do you see why we did those funny factoring on the pink sheet last week? Factors of 18 that will, a positive 18 that make -9. Okay, a -6 and a -3. Everybody checking that? -6, -3 adds up to -9, but multiplies to make 18. Good? Okay, how can we find the zeros? It doesn't factor any further. If I set this equal to 0, I get x squared equals 6, which means x equals what? Yeah, remember the plus or minus, okay? And this one? So we didn't have any imaginary ones, right? There can be imaginary ones, which means the graph does not actually cross the axis there. But we ended up with a whole bunch of little icky decimals, okay? Like a -1 point something and a -1, this is actually 2 point something, okay? And over here, positive was degree 4, so it would come down and do something like that. We didn't, it asked us that. All right, over here, degree 5, so the possible number of zeros is, nope, 5. Possible turning points is 4. There you go. All right, how are we going to factor this? Okay, take out an x. Left is an x to the 4th minus 6x squared minus 16. Can we factor that one further? Now this is down with only an x to the 4th and an x squared. So it's going to factor x squared and x squared. Factors of 6, multiply to make -16, but add up to -6. 8 and 2, which one needs to be -8, +2? Okay. So where are the zeros? This one is at x equals 0. This one would be x squared equals 8, x equals plus or minus the square root of 8, which if we are good little mathematicians, which, yeah, it'd be 4 times 2 This guy would get out of jail, 2 square roots of 2. What about this one? Yes. If we moved this over to the other side, we'd have to square root a negative. The good news today is, what does this say? Real zeros. So these don't count. They don't actually cross the x-intercept, so we don't care about them today. It would be, I think Christian said, I square roots of 2, right? Plus or minus I square roots of 2. But you really don't need that today. Everybody all right? So how many places does this actually cross the x-axis? 3. 0, square root of 8, negative square root of 8. Okay? So you have this one. All right. Predict the end behavior. What degree is this? Degree 5. Leading coefficient. Negative 3. So a degree odd function normally looks like a cubic. But this one has a negative, so it's been flipped upside down, right? So the end behavior is going to look like this. So without even graphing it, what can you tell me the left end is going to do? What is this shape telling me? The left end is going to go up, which is to positive infinity, as x goes towards the negative end. As x goes off to the right, the function is going to what? Go down on the right, yep. All right, so I know this end is up and this end is down, but anything else I would have to graph it. Can anybody tell me the equation? Thank you. So if I try a standard window, I get that. What did we just say though? Oh, but it had at most, right? Is it going the right direction, guys? Left end up, right end down. It would have at most 5 zeros, but it doesn't have to. Apparently it only has 1 0. Okay. It does have a little dip over here. I don't know. I'm not going to take time to graph this very accurately. So it's doing, has a little max over here somewhere, right? Anyway, it only asked about end behavior, so that's what I'm going to stick with. 5b. Oh, it says skip for now. Okay, because I think we just did some of these. Let's go on and talk about multiplicity of a 0. Even and odd matters. Multiplicity. I'll get wrong answers on this on a quiz. Multiplicity is just when you have a 0. This is a 0 of multiplicity 4. Okay? There's a 0 at x equals 3, and its multiplicity is 4. That means it's power 4 on that whole 0. What that means, if it's an even multiplicity, the graph doesn't actually cross there. If it's an odd multiplicity, it does cross. It does actually go through that point. Does some of you remember this from last year? Ever do this? Okay. So when you have a 0, the degree up here of the 0 is called the multiplicity. If it is an odd multiplicity, it actually crosses the x-axis. If it is an even multiplicity, it'll be tangent to the x-axis, and we could say it just barely touches. Some teachers use the phrase kiss or cross. Does it just barely kiss the x-axis, or does it actually cross the x-axis? Okay, just nice alliteration, kiss or cross, even though it's different letters. All right, so non-repeated 0 can be thought of as having a multiplicity 1. Okay, so if I wrote this polynomial, this was my whole polynomial, can anybody tell me what degree that is? It's not degree 4. Does anybody know? This would be an x to the 4th if I FOILed it all out, but then I'd multiply by this x and this x. It's x to the 6th, okay? There is a 0 where? Out here, this guy. There's a 0 at 0, and there's one at -1, right? But those are both just multiplicity 1. They're not repeated zeros, so it would actually cross the x's. So I can predict right now that if I graphed this on the calculator, it would cross at -1. It's degree 6, so both ends would be up, cross at -1, cross at 0, and then out here at 3, it would bounce because it's an even multiplicity. So much we know just by predicting from those things. So that's our job here. Part A says apply the leading term test. This means figure out what the degree and leading coefficient are. Okay, what you want to do is just look at the x's. There is a -2x. In here, there's a power of 1x. But back here, there's a 3x that's being cubed. I'm ignoring the shifts left and right and stretches and all that kind of junk. What would that turn out to be? 3 to the 3rd would be what? No, 27 times this -2 would be a negative number. I really don't care what the number is. I just want to know if it's positive or negative. And then I'd have an x, and back here an x to the 3rd. Okay, so I really don't care about the fact that it turned out to be 54. The leading coefficient is negative, and the degree is odd. What does that mean about the number of zeros? It can have at most how many zeros then? 5, okay. What does the fact that it's odd mean? Well, this is the normal shape, but the negative means it's flipped upside down, right? So it's like an upside down cubic. It's going to be this shape. All right, let's go on to B. What does B say? I'm going to put it down here, but the zeros and the multiplicity of each repeated 0. Okay, be careful. Can -2 equal 0? That's not a 0, right? That's like a stretch. But this x out here does mean there's a 0 at 0. Does it have any power on it? Like an exponent? No, so that's just multiplicity 1. Then here there's a 0 at 4. I should just write that these are the zeros. Does that one have a repeated multiplicity? Nope, but be careful. This one's not 1. What is this one? 3x minus 1 equals 0, so x equals 1/3 is a 0. And that one, you have to indicate the multiplicity, which is the exponent power of 3. Okay, because it's an exponent power of 3, does that mean it crosses or kisses? Crosses. So if we graph this, it's going to have a 0 at 0, 1/3, and 4. It's coming from up here, and it's going to cross at all of those. All right, you are now ready to work on this assignment. This weekend, it is 2.2, page 104. There's the 9 problems that are assigned. It is also on your blue chapter 2 listing of assignments, okay? These are not long and complicated, guys. Please do this homework this weekend.